Hello, everyone. We are live. All right. Welcome, everybody, to our very first Securi-Taco Tuesdays. So I'm Stacey Potter. I'm a community manager here at Stacklok, and I'm joined by my colleague, Adolfo García, who is a staff engineer here at Stacklok. So hi, Adolfo. Do you want to introduce yourself?
Yay. Hello, of course. Welcome, everyone. Welcome to the first ever Securi-Taco Tuesdays, the show where we discuss supply chain subjects over tacos. So instead of just having the tacos, we'll just eat them and share our conversations with you. My name is Adolfo García. I'm one of the engineers working on the Minder platform here at Stacklok, and I'm super happy to be here.
And I will probably be using Adolfo and Puerco interchangeably. So I'm sorry for the audience, but he goes by both.
It's fine.
So this is our inaugural season and episode. So thanks so much for being here. And please forgive us as we work out the hiccups and as we dive into this new adventure of hosting these every single month. So the series is dedicated to bring you educational content and information, as Adolfo said, on the software supply chain security topics with a variety of guests throughout the seasons. So the plan is to stream these sessions live for about an hour. So if you have any questions as we go along, don't hesitate to drop them into the chat and we'll get them as soon as we can. So to kick things off, before we get into our high-level discussion, I do want to just give a quick overview about the company that we all work for. So hopefully you've heard of us, but if you haven't, we're Stacklok, and we're passionate about making open source safer, or open source software safer. We believe that open source software supply chain represents one of the greatest technical treasures and sources of human innovation. We also see open source as a tantalizing target for sophisticated hostile actors. Malware injection into the open source software supply chain is the most significant cyber threat facing the software industry, and we want to help prevent it. Our team's background is in creating, maintaining, and scaling open source systems, including Kubernetes and Sigstore. We're drawing on our expertise in open source and security to give developers and open source communities better tools to secure their software and manage external dependency risk. We believe that contributing to open source is a necessary part of our everyday work. As part of their daily tasks, our company leaders, engineers, and PMs build, maintain, and contribute to open source projects and lead open source initiatives that support upstream communities and advance open source security. You can learn more about us at stacklok.com or join our Discord server, which you'll see at the end of this presentation, and subscribe to our YouTube channel. So with that, I'd like to invite our first guest, Luke, to introduce himself, and then we'll get into some taco time.
Thank you. What a privilege to be here. And yes, so I am Luke Hinds, one of the co-founders of Stacklok, and I've been an open source security developer for quite a few years. And so generally trying to build the platforms, tools, and software to protect open source software. And spent a significant amount of time in different open source communities, Kubernetes, OpenStack, various sorts of cloud platforms, going all the way back to a very long time ago when I got started in the Linux kernel, working on some of the firewall tech. And so really looking forward to this. I feel like this is a kind of a tall order I have to raise to. I talk about supply chains all the time, and then I sort of am on the edge of trying to describe them, and I feel that apprehension as to how I will do. I'm sure I will miss things, and my esteemed guests will prompt me there. And but yeah, it should be an exciting topic. Much.
Awesome. Thanks for being here, Luke. Thanks for being our first guinea pig.
Sure.
So, taco time. I guess we should talk about kind of how this show started in the first place. So, Parco and I met at Open Source Summit when I first got hired here at Stacklok. And I had noticed there were all of these taco innuendos in the software supply chain security space. And so I started asking Parco to kind of define all this acronym soup to me. And I said, why don't we just do a show about this? So can we talk about what is sauce, what is salsa, what is guac now, and all of these things, right? So we said, well, this won't just benefit me, it will benefit the community. So let's just do a show on it, and let's talk about tacos and security together. Adolfo, is that kind of your recollection?
Yeah, exactly. And then the idea is, well, we can sit down for tacos every Tuesday, discuss these subjects, and then if we're going to have these conversations anyway, well, let's just record them, live stream them, and yeah, have fun.
Yeah. So with that, Adolfo, what tacos are you eating today?
Well, for our inaugural episode, I chose to have the king of the taco. And this, if you ever come to Mexico, I live in Mexico City, so we have basically all of the real tacos here, representative of the taco world from each corner of Mexico. And the best ones, and this is my opinion, and I'm the only Mexican here, so sorry. The best tacos here in Mexico are the tacos de canasta, which roughly translates to basket tacos. You usually get them from a guy that rides his bike in the street. They have like these big baskets on the back of the bike, with always lined with blue plastic. I don't know why. And they're delicious. They put them inside of the basket the night before. They just drip them with like hot oil, and they're delicious. You usually get them with the green sauce that you see in the picture. The sauce, the sign of quality of a good taco de canasta is that sauce must come in a giant mayonnaise jar reused for the sauce. So if you see that, then it means it's a quality taco. And of course, I'm having the official drink, which is the guava boing that you see in the picture. And so it's, I don't know, so that sauce is super spicy. It's one of those kind of radioactive probes that you can track all the way from top to bottom, so to speak, in your body. And then you pair that with a guava flavor, artificial guava flavor, of course, from the drink, and it just runs off the spiciness that, I don't know, it's indescribable. So whenever people come and visit Mexico, I always advise them to try them, but on the very last day of the trip, because you're gonna get sick, not because they're dirty, which they are, but because the sauce is so spicy that it's gonna get your tummy going. So yeah, that's what I'm having.
Nice.
And I'm really excited.
Yeah. Well, I am not usually in London, but I am here today with Luke in our London office. And there was a place around the corner called Oaxaca, and we went and grabbed some tacos and brought them back. So this is a view literally right next to me, looking out on the streets of London. And we have a pork pibil taco, and then a grilled chicken taco with some avocado. We have the red onions that have been marinated, and some avocado on top. And then before the show started, we actually ate a plantain taco, and it was delicious.
It was amazing. It was like sweet and chili just coming together in heaven.
And it is 7 p.m.
Yeah. So we're allowed to drink
London.
beer.
That's right. So we have a Corona.
Yeah.
I'm getting close to that point, but not yet.
Yeah. Got a couple more hours. Hang in there.
But anyway, yeah.
I'll pass it over to you, Adolfo, and we can kind of start with the topic and give a general overview of kind of what the software supply chain is. And then we can kind of invite Luke on and dive into these topics a little bit more.
Yeah, it's interesting when we're talking about these tacos. I mean, the tacos that I'm having right now, they usually are made by families that come from the state of Tlaxcala, which is about an hour and a half from here. And every morning they come to Mexico City, they open their baskets, sell them. And these tacos are made out of pork rinds, which is delicious. But then when you start thinking, well, this is the story that they tell me. Did they really come from Tlaxcala? Are they really coming from a traditional family, or did they have like something of a family come from? And when you think about software and food, we always have this analogy on the ingredients that you're eating, right? And it's about the ingredients, the composition, how were these things made? And it's the kind of assurances that you need to have from software, but also food. So there's a lot of parallels, and this is why in discussions in subjects like, for example, SBOM, you get to see them compared to nutritional labels of software. So what is the supply chain? I think the best analogy is to pair it with food. And in this case, we're going to take some shots from the video that we have on stacklok.com, where we compare software with ice cream. So when you think about ice cream, you simply go to the supermarket, open up a jar, and start eating. But where did this ice cream come from? Well, it usually comes from a factory. And when we think about the supply chain, and especially for the software supply chain, you think about links all strung together. And what is essentially a link in the supply chain? Well, a link in the supply chain is that bit where a piece of software gets built. So if we do the analogy with the ice cream supply chain, you have an ice cream factory. And the first thing that you need to manufacture ice cream is, well, the source code. And so you start with the source, and then source will usually take some of your software, which is your application basically, and it'll take some dependencies, which in the case of ice cream is, milk and some sweeteners and flavors. And then you put those into the factory. You do some transformations, which in the software world would be akin to building your software. That's where you bring in all of the components together. You run them through some process that assembles your piece of software, and it's ready to use. And then you usually package it. And then when you package that software, basically it means that you take all of your artifacts and put them inside of a container. And that container is then ready to ship. And shipping is also, you also need to be careful about shipping, because, for example, in the case of ice cream, if you're not careful, it can melt on the way to the ice cream store. And then finally gets to the consumer. But the interesting thing about supply chains in general, but in particular for software, is that some of those components are really the components of other processes. So in the case of ice cream, you have ice cream, but also that ice cream gets turned into milkshakes and lollipops and ice cream sandwiches and whatnot. So any flow introduced at any part of the supply chain can contaminate basically anything down the stream and get to a consumer, which is not happy. And in the case of it's not really a happy situation if you get like contaminated food. And in the case of the supply chain, we need to be extra careful, because there are bad actors trying to intentionally pollute those supply chains of what we eat. So this is why the supply chain needs to be protected. This is why supply chain security is such an important topic. And this is why we have Luke here today to share some insights about securing the supply chain.
Good stuff. I love the analogy. And so there are many components to the software supply chain, okay, but we're going to keep it to some of the top level aspects. And like I said, I'm sure I will miss things out, because This is the software supply chain, the open source software supply chain is a very elaborate, complex spaghetti monster quite often. Okay, there's multiple humans that are involved. There are multiple machines, there are multiple processes, there are multiple artifacts, multiple workload environments where these things are instantiated as running workloads and so forth. So I'm going to try to pick up on some of the kind of the obvious areas. Okay, and I think one of the key areas which sometimes gets overlooked or perhaps doesn't get talked about quite so much, but is very obvious, is the very thing that we have sitting in front of us, our laptops. Okay, and that is very often the entry point. Okay, for unwittingly, it could be a CVE introduced or a secret that's leaked, or it could be compromised. It could be compromised by somebody else. The accounts that are facilitated within that laptop, the actions that the developer takes, and so this is it's a very key central defense realm within the software supply chain. Okay, so everything manifests here. It's the nexus, the oracle of the software supply chain. And I think we look at some of the attacks. A very, very common one is credential leaks. Okay, and like I say, sometimes these can be by mistake. Sometimes they are exfiltrated by an attacker. And we've seen that these come in many, many different guises. There is phishing attacks. Okay, and for some of the folks that are very deep into crypto and provenance, and we probably think, who falls for these? Lots of people do. Very smart developers sometimes. Okay, and these can come in the form of, you may get an email. Okay, and it purports to come from your CI provider, your cloud provider, your code hosting provider. And there's a green button and it's saying, please approve access of this app, this sort of helpful developer productivity app, or allow somebody that you believe to be part of your team to access a repo. And there's a nice big green button, pretty simple. You've done it hundreds of times before you click the button. Okay, and then all sorts of attacks can manifest from that. There's lots of nasty things that can happen. Essentially, you might be granting the application some sort of OAuth access. It could possibly download some type of malware. Okay, and there's been many times that this has been leveraged. I won't call people out, but I know some pretty substantial infrastructure sort of CI stroke companies that have been exploited in this way. And it's particularly difficult to tackle because if somebody gets access to a laptop, they get keys to the kingdom. So, this is something that scares the hell out of me is one of our, to speak as somebody that has a, part of a company, for a laptop to be compromised, there's all sorts of attack that can spiral out from that particular entry point. So I think that, the laptop is definitely a key central ground, and I think we could all be more vigilant. Do you see what I mean? I think, as developers, it's an attention economy nowadays. Your attention is a very finite resource. We tend to just click things to make them go away, but we have to be extremely vigilant. And it's not just the, people compromising browser sessions and sort of piggybacking on sort of single sign-on access and so forth. It is also the developer when you're actually developing within your local developer environment. Okay, so one of the common things that we will do is we will start a project, we will select some dependencies, and then you will use some sort of package registry tool to install those dependencies. Okay, excuse me. And quite often these, if I use one, for example, npm, okay, this can have post-install hooks. Okay, so quite often a malicious package, there might be a typo squatting attack. This is something that we've seen a lot with our threat detection platform, is typo squatting attacks on very popular package names. You run npm install package name with some slight variation of character, and there's typically some post-install hook which will then execute an executionable on the laptop. And there's one that our threat hunter, Poppy, found just a few days ago, where there's a command and control binary that was delivered within a package. And, you know, these are sometimes focused on developers. You know, there's the Macho executable format for MacBooks, which a lot of us use. And this stuff can be lethal, you know, if you effectively execute one of these binaries with a malicious payload on your laptop. All sorts of nasty things can happen. Not only is the laptop compromised, the access afforded to that laptop is compromised as well. So you might have access to different environments within your cloud provider, possibly your production network. The ability to escalate is there with administration of various platforms that you use and so forth. So the laptop is very scary, what can happen there. And quite often, maybe it's because it's obvious, I don't know, it's not really at the forefront of discussions around the software supply chain, but it's a critical part. It really is, because so much happens there. It's very much the entry point.
So I guess a follow-up question would be, what's the first line of defense against something like that, right?
Yeah, very much so. The first one is really vigilance, okay? And some of us that are at big companies, they'll make you do you get the kind of the end of year security certification that you have to do, okay? You got your kind of compulsory training that you do at the end of the year, where you learn about anti-fraud and, you know, and various things around HR. And a lot of people try to speed click through those sorts of things, but they will actually outline the simple thing of a phishing attack. Do you see what I mean? So just be very vigilant around what you're clicking on, because you can offer up a lot of permissions and access from that. The other thing, of course, as well is, you know, if you're gonna run and install packages on your laptop, use a container if you can. Use some sort of isolated environment where those packages, if they have any sort of execution hook, it's going to be abstracted away from the underlying host operating system of your laptop, effectively. So I would say containers developed within a container is a very good, sensible method to get into. You could, of course, go very deep into this and look at things like, you know,
yeah, we've seen
execution environments and, you know, and confidential computing. But generally, you know, a container is a lot better than just running this on your host effectively.
Yeah, I was going to follow up on the container. We've seen the rise of these sort of dev container environments where you have a container, it's trying to be a little bit more isolated. Do you think in the future we're going to see something like truly isolated environments that really shield your build process and development environment from accessing anything outside of it?
I think that would be ideal, because quite often, I mean, you know, lots of people use Docker Compose, so they mount volumes, they mount a drive from the host into the container. So by no means is there complete isolation there. So, you know, I could see a future where there is these sort of trusted enclaves, effectively, where you could solo execution of suspicious packages and content and so forth. The technology's there. We're not there yet. There are people trying to do that. You also have, of course, I'm not very up to speed on it, so I may be out of date here, but you have the whole kind of WASI movement, where they're trying to sort of set up capability-based systems interfaces and so forth. And, you know, and there are, of course, projects where you can run a container within a very stripped down hypervisor, effectively, confidential containers and so forth. So there's a lot to do there, but these technologies are not immediately accessible to most developers. There's a bit of tinkering involved in setting these things up. So the tech's there, it's not easily obtainable by your average developer who just wants to get on with writing code. They don't want to set up lots of security controls and so forth.
Yeah, it's all about UX and developer experience, right?
Yeah, very much. Yeah, very much. Yeah. And that's one of the things that, you know, we've all learned being in security for quite a few years. If you get in the way of developer productivity as a security tool or project, or it's hard to get adoption. And do you see what I mean? If you place a cognitive load upon a developer, it generally will be something that they want to turn off or disable or get out of the way.
Totally agree. All right, should we move to the next phase in our 10,000 foot view?
So yeah, so what would typically happen for me, I'll say typically, you know, there's many different sort of approaches within the SDLC, but you would have your code repos. So effectively a developer makes a change, they will commit that change, and they'll make a pull request, is the term that we use quite often. And the code will then be presented to a code repository. Okay. And from here, again, there is the risks that the developer may be introducing. They may have selected a package which is of perhaps malicious or is very old and contains lots of CVEs and so forth. And they also may not be who they purport to be. Okay, so developer credentials are often, not often, but are exploited effectively. So, you know, who it appears to be might not be who they claim to be. Okay, so that's one aspect. And yeah, within the, so that, you know, there's lots of, again, this is the next entry point for many, many bad things effectively. So that there's lots of controls that can be put in place here. But some of the real concerns are, of course, like I've said, you know, accounts can be compromised. We're starting to see reputation farming, which is becoming a thing where people create a persona over time. You know, they win the trust of maintainers. Maintainers are typically, you know, the ones that are on the more busy projects are usually under a fair amount of stress and pressure. And, you know, there's a certain amount of cognitive load that's put on maintainers. Okay, so when somebody rocks up and says, hey, I'll help you, it's like, oh gosh, thanks, you know, I could really do with some help, you know. So we're starting to see reputation farming become a bigger thing, specifically with the recent XY, I always get that wrong, XY utils?
XE.
XE, sorry. But it's nothing new. I mean, we saw this with, in NPM quite a while ago. There was a package event. I can't remember the name of it now. It was event process, or somebody will probably rock up in the comments and remind me soon. But that was a pretty similar thing. It was a developer, it was a very stressed developer. Somebody reached out and said, you know, can I take over maintenance? Can I help you out? And then effectively the code was backdoored. And, you know, the other attack vectors as well as secrets. So again, we're getting into this credential leakage. People by accident will check in AWS tokens, GitHub tokens, GitHub pack tokens, all sorts of credentials have been checked in. I'll admit I've done it myself before. You know, you get a little bit sort of, you know, you get a little bit ahead of yourself, you push, and then you realize, oh, so I've checked in a credential. I mean, I've recognized it and immediately revoked them, but some people don't. And some people aren't really aware that there's a risk in these things being out in the open. And there's, you know, there's folks like Git Guardian have done a lot of research around this, and they've found a really, really high proliferation of secrets within code repositories. And there is, so it's, you know, there's many entry points again from the pull request, and there are many protections that you can put in place here. You know, I mean, we work on a project minder, which will get you a real bang for your buck. Simple things like if it's a GitHub code repository, secret scanning can be enabled. You can get that free for public repos. We also have the ability to scrutinize pull requests. It's one of the things we've been working on. So if a dependency is introduced, we can perform a lookup to the open source vulnerability database to see if it's a known vulnerability. Likewise, if it's a malicious package and it's in the trusty database, that's something that we can raise. So you can have gates in place to check these sorts of things. And I mean, beyond that as well, there is the CI that typically triggers off of these pull request events that can be very problematic. You know, there is a level of privilege escalation that can be a result of these various actions. We've seen that with GitHub Actions, for example. People with forks are able to get actions to do things that the developer doesn't really want them to do, essentially. And there's a sort of you know, a multitude of risks there as well. You know, if you're using other CI systems, they can introduce risks as well. there are risks even in your code linting. I remember CodeCov, when that happened quite a while ago. I was on the Kubernetes security response team at the time and looking into the cleanup and actually speaking to the chaps from CodeCov just after the attack. They were questioning us as the Sigstore community to see how we could help there. But I remember the kind of the blowback, the blast radius of when that happened effectively. So there's these, I mean, effectively as a CI it's somewhere where you can execute scripts effectively. You can execute things. And when you can execute things, those things can sometimes be malicious. They can be nefarious essentially. So it's, there's a whole soup of different attacks that can happen in a code repository.
Yeah, the CodeCov was an interesting one because it was a real example of supply chain attack because it
Sure.
was a tool installed from a third party that was tricked into downloading malicious code into your CI to do bad stuff.
Yeah, very much. Sure.
Yeah, so there's, I guess some of the approaches that you could see how to protect this stage of your software factory by a combination of hardening your repositories and their infrastructure, a good set of machine and automation that checks the code that it's been trying to be checked in, but there's also a human factor on top of it. Things like code reviews and two-person code reviews and just making sure that the eyes are on the code that's landing inside of your repository.
Very much, yeah. And that's the magic of open source. The code is transparent. It's there for scrutiny, and it's in the open. Very, very much, yeah. And I've seen Oz mentioned about Trivy, so there are sort of SaaS type SCA scanners that are available and out there. One that I used to work on and helped maintain is a project called Bandit, which is a Python security lint code system. So it does an abstract syntax tree walk through all the different functions, looking for suspicious patterns. And that's seen a bit of a resurrection recently because of machine learning models. So people are starting to use it for finding things where, pandas will load pickle files without them being validated first and all sorts of things. And the other thing as well is with the code repository, when we're speaking about good things you can do, good habits, this is the juncture where you can start to build a credible recipe, like you discussed with the ice cream factory. You can start to introduce provenance, so you can understand where did something come from effectively. Do I have the legitimate data provenance to be able to quantify that X introduced Y, a Y was built into Z artifact, Z artifact was deployed to A infrastructure, and so there are some good habits that you can start to get into there. And this is some of the work that we've been doing in Sigstore, which the GitHub folks have taken and run with recently around attestations of the workload itself. So there's lots of good momentum underway to fix these things as well, but a lot to do still. So yeah,
there's also a lot of work needed to make sure that people are validating all of those artifacts, like all of the attestations and everything. But sure. I've seen some really nice moves as well on that front. All right.
And salsa, of course, talking of tacos.
Exactly.
Yeah,
like producing, like salsa provenance for your artifacts and doing it in like different levels of adoption is provides like an easy on-ramp for people trying to produce more provenance metadata.
So I'm going to be the noob, someone who's not a security expert, but I've heard salsa. I've heard the term salsa, but can you guys speak to kind of what that is? And I know we'll probably have someone from salsa on at a later date to really dive in and dig into it a little bit more. But can you give us a quick overview of salsa?
Sure. Shall I get that? And Adolfo, let's tag team on this, okay? So I believe it is software levels for security artifacts.
Software levels for supply chain artifacts.
Supply chain artifacts. Thank you. So essentially, Salsa is it's a framework, okay, which is built upon Sigstore and Intoto, two projects that have been around for quite a while. Okay, Intoto for a good few years now, and Intoto was sort of something that has a very close synergy with Tough as well, which is another project you hear about, the update framework. And Salsa essentially is it's a credible provenance of a build attestation. Okay, so effectively you can understand the entities that were part of building an artifact. Okay, and Salsa is really good because it gives you these pragmatic levels that you can walk. Okay, to improve your posture, your supply chain posture. So the very first one is very, I believe, again, people can correct you if I'm wrong, but do you have a make file effectively? Do you have these basics that are in place that give you a lot? And then you walk up to 1, 2, 3. 3 starts to introduce cryptographic properties. Okay, you start to sort of, get bits and bytes guarantees around the integrity of the build attestation, the build provenance. And Adolfo, you could probably, go a bit deeper into this. I believe 4 starts to look into even hardware attestation.
Yeah, so there was a change from Salsa 0.x into Salsa 1, and now we have tracks. So there's a build track, there's a source track, and the idea is, can I advance these levels independently whenever I'm trying to address any of these components? So the idea would be, in Salsa 0, there are no guarantees. I give you software to run it. You don't necessarily don't have any assurances. Then as the levels increase, I give you provenance that can tell you something. Then it's the next level. It's about producing, for example, starts making things a little bit more strict. And then, for example, you have to sign your provenance attestations. And then also, for example, it hardens your build environment. And then it starts adding requirements so that the build process cannot modify the provenance file, and just starts going up and up and up until basically you reach that idea of Salsa level 3, which is your super hardened environment. And before, we used to have like a Salsa level 4, but some people, I remember that when we were working on the Salsa effort for the Kubernetes project, and there were some claims that, Salsa 4, don't worry about it because it's impossible to reach. No one can do that. So people went back to the drawing board, and then the spec started to discuss how can we make this easier to adopt for projects. And then that's how we ended up with Salsa 0 to 3, and then split into these tracks.
You get some really rich contextual information as well within a source of provenance. That's things such as compiler semantics. For example, Go, there's certain flags that you can pass in. And so the idea here is that you can almost have some level of build reproducibility. You can look at how the artifact was built, what flags were used, and so forth. And things such as the commit SHA that the artifact was built upon. So you start to get some reproducibility there, which is very, very powerful.
Yeah, exactly.
As a means, yeah.
Yeah, the idea of the Salsa provenance, it's a recipe of the software. This recipe, like, how do you make the salsa? And then you have the set of ingredients. Then you have the recipe, which is basically what did I run to perform this transformation on my source code, the ingredients. And then finally, what was the output? And it gives me a bunch of subjects that I can cryptographically verify to make sure that they check and everything squares up with the inputs I have, the process that I run. There are security guarantees for the builder that I'm using in that recipe, and also the hashes of the final output so that you can cross-check everything.
And it's your baby steps sort of framework to kind of get where you want to be.
Yeah.
Yeah.
Which is beautiful. I think that's, that's so useful to people. Because I always say, with security, do not let perfect be the enemy of good. Do you see what I mean? Some people believe that if you don't have this kind of cast iron Fort Knox, everything is protected with crypto, and it's just not good enough. Well, no, small steps are good. Any sort of improvement is a good thing. It's a good thing.
So we had a question that came in from Carlos, who asked, can you give some examples of tools that we can use to achieve the salsa levels?
Adolfo, I'll let you get that one. I mean, I know there are some within the salsa organization itself. I remember there is various tools and actions and so forth. But
yeah, we may be getting into a future episode, but it's
sure.
okay.
Yeah.
So yeah, there's the salsa project itself has a Go builder that will run your Go builds in a controlled environment. They capture all of the data and plaster that into an attestation. That's one. It also has a generic build mode so that you can execute basically any builder that you want. And I'm sure there are others, but I'm going to shamelessly plug the one that we wrote for Kubernetes called Tejolote. So Tejolote is the mortar. So in Mexico, we have the mortar called molcajete, where you do the salsa, and the tejolote is the hand piece that you use to crush the salsa. And we produce that for Kubernetes, and that's the tool that builds the provenance attestations for some of the projects in the Kubernetes organization. And those are the ones I'm familiar with. I'm sure there are a bunch of others, but off the top of my head, those are the ones I can remember.
Do I have that GitHub link?
Yeah,
correct?
That's it.
It's one of the things we're doing in Minder as well. Is starting to look at, measuring the policy effectively around these attestations. Do they conform to what you're declaring they should? So.
Yeah, exactly. So yeah, the idea is one of the functions that we've built on top of Minder is if it finds, you can configure policies to check those attestations. So to make sure that any artifacts that you're publishing really came from that build process, from that specific builder, from the SHA commit that they're claiming to be, and so on.
And to tie it into the code repos, again, there is this sort of immutability. I mean, if we look at GitHub Actions, you can effectively fix actions to tags or commit shards. Okay. So if you tie your action to a commit shard, and then it generates a provenance, which then effectively is mapped to a commit shard, you start to get this sort of trackable paper trail, breadcrumb trail, I guess is the word. Cool. So we've done the code repos. So next would be the build systems, which we kind of discussed as well. We kind of got into the build systems. There is, I mean, there are many types of build systems. So of course, we could get into multiple types of scenarios that there are, but perhaps it makes sense to move on to the artifacts. Unless, Puerco, there's something pertinent that we've missed. I think so.
Yeah, I think we touched on some of that.
Sure. So artifacts, yes. So essentially, an artifact is the result of a build process, typically. Okay, so something effectively builds an artifact. It's a packaged expression of software. So it's an element that contains all of the capacity needed for that software to run to run as it should. The dependencies that are needed within the language ecosystem and the runtime OS requirements that it has, platforms, software and libraries and so forth. And, there are, of course, again, we can discuss how we had the entry point of the developer's laptop where they introduce a myriad of different risks. And one that we saw recently was a GitHub PAT token for the PyPy folks, managed to get rolled up in a container image. which somebody luckily caught. Okay, so many of these earlier prior art expressions of the development flow can be packaged effectively within an artifact. Okay, and so I guess that, you know, if we to look at the different artifact types, of course, there's container images, quite a common one that's used a lot nowadays. Okay, and you know, that if packaged with perhaps malware, there could be CVEs within the image. There is a lot of images out there that are hostile. So you could select an image which is compromised. Again, there was some research. I don't have the figures to hand, but I think it was, yeah, I think it's JFrog. I've got it here. So nearly 20% of the repositories on Docker Hub contain malicious content. So Bitcoin miners, malware, and so forth. So there's a lot of bad images out there that could introduce risk. And, you know, and there is, of course, you know, other artifact types, tarballs, or even a binary blob, effectively, you know. And again, so we're looking at these, we're starting to build a tapestry of how the supply chain can be secured now, where we have the provenance, we have the checks, the gates, the controls, to make sure these risks aren't introduced, because as soon as they're introduced, they're further propagated along the supply chain to the workload. And an artifact is yet another expression of that can introduce its own specific risks as well.
Yeah, so can you talk a little bit about, so we always discuss, because we're so close to it, we always discuss about Sigstore, right? And Sigstore is the ideal tool, you know, to sign those artifacts. So I think sometimes people just think that because they sign an artifact, they already achieved like the holy grail of security. But could you elaborate a little bit on where Sigstore can help and where you need, I mean, where its effectiveness ends, and then you need to also, you know, have additional information and metadata to make sure that the artifacts are secure?
So essentially, I mean, signing in Sigstore, it gives you truth in data, effectively. You have guarantees to a degree on who produced something. Okay, so if we looked at where we were speaking about Salsa and Intoto and Sigstore, okay, so effectively you can build this chain of cryptographic attestations to show that a certain party or a certain build system signed a container image as part of a build process. Okay, and like you rightly say, just because something's signed doesn't mean it's good. You know, it could be incredibly bad, but it still has a signature. Okay, and so it doesn't really give you guarantees that something is quality, but it does give you the ability to quantify specifically where it came from. Okay, and then be able to block it effectively, you know, based on certain policies that you might apply within the SDLC. So effectively, it's, you know, it's getting a snapshot of the truth. Okay, potentially where something was built, or who built it, or who signed it. So that's the main thing. And I mean, the other thing with of course talking about Sigstore is that signing is manifested publicly. Okay, so it's observable, it's transparent. If you see what I mean. So you can then rely upon the principle of something's observable. Okay, pretty much like open source code, it's observable. It's you know, you've got that open, credible record that can be consulted.
Yeah, and another important guarantee that signing gives you is that artifact that you're holding has not been modified.
Exactly, yeah. The integrity
which is something that happened to, I think, the PHP project at some point, that one of their mirrors got compromised and then they swapped some of the artifacts.
Yeah, very much.
Yeah, which ties nicely to the next level in the 10,000 foot view.
Yeah, very much. Yeah, no, and just to elaborate on what you said, there is, you know, multiple attacks where that happens. You know, there's a tampering, okay, and a signature will verify that tampering has occurred. I remember there's a Linux distribution called Linux Mint, and I remember their ISO was swapped out, and they had the checksums on the very same site where they hosted the links for the ISO. Okay, and that's obviously, you know, you're kind of sitting on the branch you're soaring, effectively, you know. And I remember speaking to, I won't name them as such, but you could probably guess, there's a particular operating system that is used by whistleblowers and journalists, and people operating in very dangerous situations that they use. And they were doing a similar thing, sort of, you know, everything was stored on a website. So you effectively got the public key, the ISO, everything from the same source. So yeah, so we now get on to the infra, okay? And as always, you know, it is a further expression and manifestation of everything that's been introduced prior to this juncture. And here, you know, there is, you know, we could sort of extend the premise of cryptographic signing. You know, we spoke about you could effectively gate using these provenance attestation controls around integrity and source of origin, these sorts of things. But there is also some very, very low-hanging fruit as well, okay, around so many people fall prone to just deploying things with default credentials, okay, to start really simple. I remember the everybody remember the MongoDB admin default password, which was running absolutely everywhere, effectively. So there was loads of insecure MongoDB instances. So quite often, you know, that is a prolific attack angle. Sometimes, like I say, it's not about getting the sort of the iron tight cryptographic, low level hardware tested Fort Knox environment. It's just changing the default password. Do you see what I mean? That can get you so far. So that's where sort of, you know, starting the basics can give you a really good boost. And there, you know, there are multiple other things, like, you know, there is the permission sets, the access control systems that are put in place. Are those properly configured? We've seen multiple times S3 buckets be publicly open when they're not meant to be. So there's a multitude of attacks that can happen in the infrastructure as well, you know, and predominantly a lot of the time there it's very simple things that trip people up. It's default configurations. It's a non-hardened environment, but things have got better there. I mean, you know, over the years, what we're starting to see now within the workload is zero trust is starting to become more of an intrinsic, out-of-the-box available feature in a lot of environments. It's quite normal to get namespace-based isolation on firewalls and all of these extra controls baked in, you know, like an SSH key can be easily created to connect to an instance and so forth. So things have vastly improved there. And I think that's actually resulted in really lifting security a lot within the workload. Okay, one of the things that I'm aware of is, I don't know if they've done one recently, but Red Hat used to do this security report. So they obviously maintain lots and lots of packaged expressions of open source projects, both language libraries and OS libraries and OS tooling and so forth. And they found, I think it was 2000, and I don't have the date here, but in one particular year, there's 1,656 documented vulnerabilities. But out of those, only 7, wow, which was 0.4%, were exploited in the wild, you know. So things have got a lot better. And I think that is really because of the nature of the environments we deploy to now. You know, zero trust is very much baked in, you know. Workloads are generally more short-lived, effectively. They're not sort of long-term running systems. I mean, I'm a bit of an old guy, and I remember when I started out, you know, you'd get a big old server. You know, this thing would weigh probably 2 kilos, and you kind of put it in a rack, screw it in, put a network cable in. One was good, one was bad. One was inside, one was outside. And the thing would be left running for months. Do you see what I mean? You used to type uptime on these things. And there's a bit of a bragging right. Some people would say like 4 years, 6 months, 10 days, 12 hours, 56 seconds. Do you see what I mean? But I think really, you know, that the CVE is less of it's a harder target to meet, to reach rather, in these current environments. And there's lots of really good efforts going on there. I know Adolfo, the great work you've done around VEX, to really understand the reachability of these things, because it's a very large cognitive load on people. The attrition of constantly trying to backport and fix these CVEs. It's a thorn in the side of many developers and security teams. And so that's my kind of guys on the infrastructure. I probably missed some really obvious ones, which you're going to remind me of now, Adolfo, and I'm going to think, oh God, how did I miss that?
Yeah, whenever I think about the infrastructure, to me, it's that conjunction where the supply chain meets the deployment. Because once you, especially for serving infrastructure for software like registries and buckets where people download things, once your artifact hits some of those registries, all sorts of automation just kicks down in the supply chain, and CI processes start, and like canary processes to build. And so if attackers can get a hold and inject something in that infrastructure, they can effectively stream down their malware. And the concerning thing is that it sometimes gets like not really considered inside of some of these practices and frameworks, because it's so vast and so different that it's also, I don't know, easy to forget that it's there.
Yeah, and secure code practices really come into their own. Yeah, effectively, but folks will be aware of OWASP, the OWASP top 10. Anybody that is a JavaScript developer should know those. They should know them like the back of their own hand, effectively. And because that is the new attack angle, effectively, is the serving endpoint, the front end, effectively. And so again, not only is there these sort of good controls that you can have these gating systems around scrutinizing dependencies and code lint scanning, to look for things like use of a val, shell execution, unsanitized input, all of these sorts of typical exploit manifestations that you get in code. Those can really, really give you a bang for your buck, effectively, having good secure code practices in place, because that will be the next battleground, effectively, is that sort of that external rendering of your software.
Nice. All right, well, coming to the top of the hour, Stacey, I don't know if you want to.
Yeah, no, I was just going to say thanks, Luke. And we can have you back on at a later episode to expand on some more of these topics.
And I know you've got some really good experts queued up to come on here. People from many different projects, many different vendors. And so I'm really looking forward to watching this show grow and seeing the people that come on here. I've seen some of the experts you got queued up, and I am excited. I really am to watch some of these. So see some good things happening here.
Thanks so much for being here. And thanks everybody out there who's watching, or if you're watching this afterwards, we appreciate you being here. Check us out at stacklok.com. You can join our Discord at discord.gg/stacklok and subscribe to our YouTube. And all of these shows are going to be listed on our meetup, which is meetup.com/Stacklok User Group. So hit us up on all those places. And we look forward to seeing you on the next one.
Yeah, thanks everybody. And join us next month for another interesting and fun conversation with some other special guests.
And new tacos.
Yeah, more tacos.
Thanks. Bye-bye.
Bye.